Hey, what's going on, guys? Komakikins here. In this video we're gonna finally implement our IsSquareAttacked function, intended to answer a simple question whether the current given square is attacked by the given site or not, and if it is so, we'll return 1, which means true, otherwise we'll return false, which means 0, which means false. And assuming that we already have the pre-calculated attack tables for both leaper and slider pieces, it would be really trivial to implement this IsSquareAttacked function. So without further ado, let's actually start. So I would like to open the terminal in the current working directory, and by typing make debug, compile the code, and if it compiles, just run bbc binary executable. So this is the output from the previous part, which we don't really need that much, so let me try to get rid of this and actually show you one little trick here. So I want to parse the fen string, and let's reference this empty board as an example and put it here, and let's put a pawn on e5, on d5, black pawn on d5 like this, and just want to print the board. Okay, so we got our pawn on d5, and now we will be asking the question whether the square, well, let's say e4, whether e4 is actually attacked or not. So in order to do this, we need to do the following thing. Before that, I just want to print a bitboard containing bitboards and the black pawn. So to give you an idea how the black pawn bitboard looks like, so here we got a pawn on d5, and also now I want to print the bitboard, the following bitboard. So if you just say reference the pawn attacks for white pawns, which is important really, so for white pawns, and on the square that we want to figure that out whether the square is attacked or not. So in our case, this is the square of e4, so square e4, and we just print the attack map. So here is the square, we're wondering whether it is attacked or not, and here is the attacked bits that are generated for white pawn being on the square of e4. And now if we just bitwise end this bitboard and this bitboard, then what we'll get in return, we'll have this like bitboard, right? And that means that actually the square is attacked, because we have a black pawn on the target attack, on the square attacked by the white pawn, standing on the square where we're asking actually, is this actually attacked by the black pawn or not? So if I just try to print bitboard, and I'm using this white pawn attacks paste, and I just bitwise end this with bitboards of the black pawns, then it would have given me this like bitboard, and obviously this value means true. It's not 0, it's a positive, not even a positive, it's unsigned value, so it's a non-zero value, which means so this would return true. So if we evaluate this expression, it would return true for us. So we can simply say like printf, let's say is what square is e4 attacked by black pawn, and decimal, new line, and here we can just evaluate this expression, copy, and if it is attacked, we just want to print 1, otherwise print 0. Okay, so we have this, or we can even say like, if it's string here, then just simply say like yes or no. So we see like, is e4 attacked by black pawn? Yes, it is attacked. So this is the e4 square and this is the black pawn. So black pawn bitboards, black pawn's bitboard, attack mask for white pawn on e4, and then we bitwise ending, and at the very end, after evaluating this expression, we have the value, the true value, this one in particular. So that means that we may print yes, or in our square attack function we would be returning true in this like cases. And same would be for the black, if we want to ask whether the square is attacked by the white pawn, so would I be generating black pawn attacks respectively, and bitwise ending with a white pawn bitboard. And for all other pieces but not pawns, it's gonna be the same, but regardless of color. So when we would be dealing with the pawns within the IsSquareAttacked function, we'll need to add some conditions regarding the color to make sure the attacks are evaluated properly. So I would now start implementing the IsSquareAttacks here, just right over in here about the main driver, and later on I'll put this into a proper place within the attack section of the source code. So function IsSquareAttacked but is, let's say, current given square attacked by the site, by the given site, by the, let's say, current given site, like this. So this would be integer, right? Because it would be returning either 1 or 0. So we can also make it static inline integer, just to make it faster, because we would be calling this really numerous times within our move generator. So static inline int is square attacked, like this, and it would be taking the integer square as the first argument, followed by the integer of site as the second argument. And by default it would be returning false, so the square is not attacked, so return 0. And also, in order to test this function, it would be a good idea to create a routine to actually print all the squares, like whether they are attacked or not, basically. So that's another thing to consider, and I would probably start exactly with implementing that sort of a logic here, and later on probably even convert this into a function. But first I just want to loop over board ranks, and well, probably yeah, let's already create a function for it. I believe this would be a better approach. So we want to print attacked squares. Okay, so this would be the void print attacked squares, and yeah, so a void function, and here we can go for loop over the board ranks, and I can simply say for integer rank equals 0, rank is less than 8, rank plus plus, same for false, so for int file equals 0, file less than 8, and file plus plus. We want to, so here we loop over board false, and we want to initialize current square, so, or otherwise we want to convert files and ranks to the square, but let's better call it like initialize square. So int square would be equal to rank multiplied by 8 plus fol. Then I want to print ranks. So I can say if not fol, so if fol is greater than 0 basically. In this case we can just print f and the decimal specifier followed by 8 minus rank, basically like this. And also we want to print new line every rank, so printf and the new line here, and let's actually try to call our print attacks our function here. So print attacked squares, so print all attacked squares on the chessboard. Okay, so we got our ranks, good, and after I just want to print false, so A, B, C, D, E, F, G, H. Okay. Okay, and here we would be calling our SquareAttacked function. So check whether the square, whether current square is attacked or not, and I'm calling here IsSquareAttacked, and okay, also this print attack squares would be taking the side, I believe. So side, so which side to give the attack squares for. So IsSquareAttacked and square and the side, so square and the side. And I just want to print f. I just want to print, well, either 0, no, not like this, probably so let's make use of ternary operator here. So if it is attacked, then 1, otherwise print 0. So let's have a look to a few arguments. So print SquareAttack for by the white pieces. Okay, so one more little thing here. I just want to keep the layout the same way as I'm doing in all the, like, print board, print bitboard, and things like that. And also let's print another new line here, so to make it a little bit, to make the layout a little bit more prettier. Okay, so by now it returns 0 for all the possible cases, and as far as we're supposed to be implementing our IsSquareAttack function, it should start printing some colors for printing some ones to flag that the current given square is actually under attack. Okay, so let's have a look. Now we have our black pawn, and yes, side parsed from the FE and doesn't really matter that much at the moment. So so we need to print IsSquareAttacked by white pieces, and well, let's actually start. Let's make it a white pawn first. Okay, So this square should be attacked, and this one as well. And okay, so if, and now we need to make sure that side is equal to white, and so if side is equal to white, that means that we want to get squares attacked. Oh my god, hold on guys. Yeah, we want to get if the current given square is attacked by the white pieces. And in case of pawns, so let's say attacked by pawn, and in particular by white pawns. So we need to generate the attacks for black pawns on a current given square. So if we just say pawn attacks and black pieces for black for black pieces, and on the current given square, and we want to bitwise end this with the bitboards indexed by the white pawn. So to make sure that the white pawn is available in one of the squares that are marked as attacks for black pawns. So that's how we know. So just what has been explained already in the very beginning here. And in this case, we want to return true, or 1. So let's have a look. Okay, so it's perfect. Now we have this c6 and d6 squares. So this one and this one are marked as 1s, which means that they are attacked actually by the white pawn, by this one in particular. So in case if we just try to put some more white pawns onto the board, so let's try to put one more white pawn. So we have respective attacks for this white pawn. So c3, e3 here, and c6 and d6. So this square, this one, and this one are attacked by the white pawns. And now we just if we just try to see this for black pieces, save, it won't be printing anything because we didn't yet generate attacks for those pawns. And now let's turn the pawns into black pawns like this. So, and provide the condition for black pawns to consider. So I just grab the entire code and say attacked by the black pawns, and side is equal to black. And now we're generating white pawn attacks, and bitwise ended with the black with the bitboards indexed by the black pawns, by the black pawn piece code, which means we're looking for black pawn bitboards. If there is a pawn on the square that is one of the squares generated by attacks or by the white pawn attacks bitboard. Okay, so it now should print, yeah, so now it prints this squares, this and this. Okay, c1, e1, c4, d4, just to see that pawns are available here. And the same actually for pieces, but for all the other pieces, but it's even easier to consider basically. So I just want to let's take a white knight at the moment. Okay, so we would be generating attacks assuming this white knight, so printing only those squares that are actually attacked by the white knight. So here we can say, so attacked by knights. So we would be using one line to take care of to both colors in one run basically. So we need to use our knight attacks and generate them for a current given square. So let's consider that we have our knight on here on d5, and now we just and this is the exact square we're asking, is this actually attacked by the knight? Well, in this case it's not attacked, but if we generate the squares, the knight attacks, and if on one of these squares there would be actually a white knight, that means that this square is actually attacked by the white knight. So that's quite pretty simple idea here. So we want to bitwise end this, and now depending on side, so I can say side equals to white. I could have say like not side as well, like this, but it's a little bit too obfuscated. So let's this is the case where I want to make things as clear as possible. So if side is equal to white, we need to reference bitboards indexed by the white knight, and otherwise we want to reference our bitboards indexed by the black knight. Okay, so let's have a look what we got now. So okay, oh, that's because we're making this for black pieces. So if I just but hold on a sec. Yeah, so if I just make it a black knight, still doesn't work for some reason. Okay guys, so okay, so I just forgot to return true. Obviously that's the reason why it doesn't work. So now this should work actually. So let's have a look. Oh man. Oh, hold on a sec. Man, what have I done? Not bitwise end, not asking this condition, this expression true and this true, but bitwise operation obviously. So like we've been doing here. Sorry. Okay, so we got a white knight, and for this square it is attacked by the white knight because white knight is here. Same for this square, for this one. And if we just try to change the color to black, it now would give an empty bitboard because there is no actually black knights on the board. But if we make this knight black, in this case we see that this square is actually attacked by the black knight, which is here. So here we got the black knight. Same for this square, for this, and all the other squares actually. Okay, now let's do the same for a king, because king is the leaper piece, and it would be slightly different for sliding pieces. But anyway, so let's first make it for a king. So attacked by king, and we have the king attacks, and we want to return either white king or a black king here. And yeah, now let's actually test this as well. So let's put a white king. Let's have a look. Okay, hold on a sec, did I forget to what's now? King attacks. Oh, that's because this is for black, or hold on a sec. Yeah, so I just need to make it for white. Okay, now we got this attacks, the squares attacked by the white king. So for every of these squares, so we got a king attacking all of these guys here. Okay, and we go for black pieces. Now it's nothing because no black king on board, but if we just add some black king, yeah, now we got this square is attacked by the black king. Good. And now let's go for implementing our slider piece attacks. It's gonna be a bit more complicated, but not really that much. So let's first try to put, let's say, white bishop, and we would be generating attacks for white pieces again. And I just want to print the bitboard, not with the white bishop, but with the occupancies of all the pieces. And as far as we have the only piece on board, it would be just right on its place. So occupancies indexed by both colors. So occupancies for, get away from me, get away. So just fly torturing me. Okay, so occupancies. Okay, so this is the attack. We didn't yet implement this, and here we have the occupancy bitboard. So whatever places we put on board, they would be represented here as occupancies. Let me just quickly show you this on somewhat different FENs. So if we say like Parse FEN and let's say start position. Okay, we got this. So these are the attacks. We don't really need to care about it at the moment. But here is the occupancy for all the pieces, like for white pieces and for black pieces. But obviously we have the only piece. That would be the only piece on the occupancy bitboard. So just to bear this in mind. Okay, and here let's have a look again. So we have the occupancy for our white bishop, or if it was whatever piece, it would be the same. So we need our occupancies both in order to pass as an argument to get bishop attacks, get rook attacks, and get queen attacks. That would be referenced in the pre-calculated attack tables for sliding pieces, assuming magic bitboard implementation. So here we can say attacked by bishop, by knights. Let's make it in plural, bishop, kings. So attacked by bishops. So we can say if, and don't forget to return true, to return 1 or true, obviously. So we can say get bishop attacks, and I forgot the order of how the get bishop attacks. How the bishop attacks. Taking the arguments. What kind of order they're taking the arguments there? So no, not this one. Not this one. Okay, it's gonna be too long. Get bishop attacks. So it takes the square followed by the occupancy. Okay, so get bishop attacks, and first argument is the square, and here occupancies. This means like both occupancies. So you remember that our pre-calculated attack tables don't distinguish between white pieces or black pieces. They just deal with board occupancies overall. So, but in this case, it's literally enough just to make it like this, and because we don't really, because we distinguish this side right over in here. So we're getting our bishop occupancies, and here we want to bitwise end this with exactly the same expression, but obviously we need to reference white bishops and black bishop bitboards respectively. Okay, so yeah, now we have squares that are actually attacked by the bishop, assuming the bishop is right over in here. So just to test this a little bit more, I want to, let's put some piece, well, let's say on e6. so here, and let's say for let's put, I don't know, like what piece that doesn't produce any, let's make it a rook like this. So yeah, so you see, like we have this rook, and what squares are attacked by the bishop? So this square f6 is attacked by the bishop. Okay, all these squares are attacked by the bishop because nothing there, nobody there to prevent this attack race from going to the edges of the board. But these two squares are not attacked because there is a rook that stands on the way of the bishop. So only this e6 square is actually under attack, which is represented. So this is the occupancy bitboard. Even if it was a black rook, the occupancy bitboard would be the same. So the color of rook doesn't matter in this case. So let's even make it a black rook to give you an idea that the color of rook doesn't matter that much. So now we have the black rook, doesn't matter. So we have exactly the same occupancy bitboard, because occupancy bitboard doesn't care about the color of pieces. It matters only regarding the occupancies, basically. And yeah, so we have only this square, only e6 being attacked, but f7 and g8 are not attacked kind of at all. So yeah, this is kind of it. So I hope the idea is quite pretty clear already. And if we just try to make this bishop black and run this again, and I'm just wondering, hold on a sec. Yeah, and I want to print the attack squares for black pieces. It would be literally the same value, because yeah, all the squares attacked by the black bishops are the same. And again, if we just make this rook back to white, it won't change anything, because it's just a matter of occupancy, not the color. So this square is attacked by the black bishop, obviously, but not all the other squares. Okay, so okay, now the very last thing left here, we actually want to generate attacks exactly the same way for our rooks and queens. So attacked by rooks, so get Rook Attacks, square occupancies both. This is the same, and the only difference is that we're referencing the rook bitboards. Okay, and here get queen attacks, and side is equal to white, and we're referencing the queen bitboards respectively. Save. Okay, yeah. So let's have a look. Now we can, I just want to parse, well, let's parse our start position. Let's say start position. Okay, and all the squares attacked by the white pieces. So this is how it looks, or no, by the black pieces in this case. So we have this squares attacked either by the pawns or knights. So knights here. Now this square is attacked because rook attacks, right? So that's the reason why we have. Let me just get rid of these occupancies. Don't really need them anymore. Save. Yeah. So these two squares attacked by king and queen respectively, and they are attacked by each other. So all this square is attacked. Let's check this. So rook attacks this one, this attacked by bishop, this attacked by either king or queen, attacked by this one is attacked by the bishop, yeah, and this one is attacked by the rook. So the only squares not attacked are the rooks, and this is represented respectively. Obviously, it's not the way of checking whether the IsSquareAttacked function is working or not. We will know this for sure during the perf test, obviously. But let me just quickly inspect the source code that we've just written in order to make sure that it actually, at least visually, correct. Okay, so we have if white to move, then we generate an attacks for black pawns, and bitwise enter with a white pawn bitboard, return true. Okay. If sided move is black, we're generating white pawn attacks and bitwise enter with black pawn bitboards. Okay. Knight attacks. So if side is white, bitwise enter them with a knight with a white knight bitboards, otherwise with the black knights. In case of slider pieces, so square and occupancies are all the same, and we just change in our bitboards to reference. Yeah, and same for king. Well, at least this looks like it should be. It should work quite pretty nicely. I'll probably, let me just try to print the tricky position and to generate attack for it as well, because I remember it visually, like how it should look like. Obviously it's not the way of testing attacks, but still. So let's first make white pieces. Okay. Yeah, so let's start comparing. So we have all this being attacked. Okay, this is attacked by the knight. Okay, this is attacked by the rook. But yeah, so that doesn't really tell much, because yeah, it also takes into account actually attacked by own pieces. I mean, like, okay, but visually I see that it looks like how it should be actually. So black. Anyway, His Majesty perf test would show if something would actually gonna go wrong. Another way of testing, like how I'm usually doing this, is just try to take a working IsSquareAttacked function from the other engine that, let's say, you've done previously, and try to compare that as well. So anyway, I'm not gonna be wasting your time anymore, guys, and I will make sure that this IsSquareAttacked function actually works properly, and if I did some mistakes, I will definitely fix them and let you know where exactly they were done, if any. If not, we'll just move on. We'll just go on developing our chess engine. So this is it from my side. Thanks for watching. Until the next video, and take care.